Good morning. This lecture is about the logical operations, namely conversion, obversion, and contraposition. So in this lecture, we will learn a procedure for manipulating categorical statements. So in the following, we will learn how to perform each operation, how to diagram the resulting statement, and how to tell whether the resulting statement is logically equivalent to the original. Before I talk about the three operations, logical operations, I wanted to do a quick review on some important concepts. First of all, for those of you who already know, and for those of you who don't know, categorical logic is a system of logic that studies the categories. What are categories? Categories are groups of things. Arbitrarily, you can group any sort of things: bottles of water, bicycles, pillows, pizzas, etc. Now, the categories are best, I think, understood when we use Venn diagrams. Venn diagrams are circles, and depending on how we overlap them, we are able to make categorical statements. So let's start with a quick review of the categories, what a category is, and what the X and the shading mean. Now, a category, as I said, is a group of people. Think of it as a container. For example, I have a container, this circle that you're looking at, and I label it blonde people. And what I mean is that in this container, I have all the blonde people that exist. Now, when I place an X inside any category, in this case, the category of blonde people, I diagram something very specific. And that is that there exist some blonde people in my category. So in other words, that the category of blonde people is not empty, but there are some individuals, some members in existence. Now in logic, remember that X means some. And some, in logical terms, means at least one member. Now, if I have the same family or category that I labeled blonde people, and suppose I place an X outside the category. Now, obviously, outside blonde people is going to be everything else. Now, you're not going to find any blonde people outside here. You're going to find everything else that is not a blonde person. So the X outside indicates that there exist some things, at least one, and that thing is not a blonde person. I can also use shading. In categorical logic, we use shading. Now, when I shade, like in this case, completely my circle, shading is essentially like sealing the container, sealing the circle, and therefore indicating that nothing exists in here. So that, in other words, that the blonde people category, the family of blonde people, is completely empty. There's nothing there. Or in other words, there aren't any blonde people. Well, what if I shade outside, the outside portion, the outside area? Well, in that case, remember that outside the category of blonde people are supposed to exist everything, every other object, every other person, everything else that is not a blonde person. Consequently, if I shade and I indicate that there's nothing outside, okay, I mean that everything is blonde people, that there's nothing else in the universe that only black people, because the outside, which would be the so to speak, the container of everything else, is empty. There's nothing there. And essentially, what I have been talking about is the four logical areas. Remember, when you make a categorical statement such as bananas are yellow, or dogs are mammals, any other categorical statement, in order to do that, you use two circles, two Venn diagrams, and you overlap them this way. When you overlap them, you form in between, as you can see, there's an I shape. And when you overlap two categories, S and P, so the subject, S for subject, P for predicate, the subject could be anything, the predicate could be anything. As I said, bananas, yellow things, objects, and so on. When you overlap two circles, what happens is, as a result, four different logical areas are thereby formed. Now, it is very important to understand the four logical areas that result from overlapping two circles. The first area we call logical area 1 contains only members of S. So if S, the subject, is bananas, and the predicate is yellow, S, bananas, okay, area 1 contains all the S, but which S? Only bananas, in this case. There are not yellow things. In other words, here in area 1 you will find green bananas, red bananas, blue bananas, any banana that is not yellow. How many yellow bananas are you going to find here? 0. 0 yellow bananas. In area 2, you will find only members of the subject. There are also members of the predicate. So let's go with with our categorical statement. All bananas are yellow. Now, what are you going to find here in area 2 are only bananas that are yellow. You're not going to find any red bananas or green bananas. 0. What about yellow objects, yellow things? 0 yellow things in area 2. All the yellow things will be in area 3. Okay? Area 3, only members of, like in this case, the predicate is yellow things or yellow objects, so you're going to find only yellow objects. 0 bananas. No bananas here. And the last one, outside area 4. Area 4 contains everything else that is not an S, that is not a P. Not a banana, not a yellow thing. The next thing that I wanted to show is how to diagram the four categorical the four categorical forms. The first form is the A form, which is all S are P. So, for example, all bananas are yellow. Now, notice that area 1 is completely shaded, because in order for me to say that all bananas are yellow, remember, I have to eliminate, so I have to shade in all the entire area where bananas that are not yellow would exist. So because I want to say that all bananas that exist are only yellow, then I have to eliminate all the bananas that are not yellow, which would reside in area 1. The second categorical form is the E form. Remember, the E form says that no S or P. And as you can see, if I want to diagram exactly the an E statement that no S or P, no bananas are yellow, I have to divide, I have to shade in area 2, logical area 2, because remember that logical area 2 is the one that contains members of the subject. There are also members of the predicate. In other words, bananas that are also yellow. So by shading area 2, I separate them. And all bananas are bananas, but no yellow bananas exist. And all yellow objects are yellow objects. And no bananas exist in here. The third form is the I form that says, remember, the I form is particular, but I'm going to talk about that in a minute. The I form says the sum S or P. That's why there's an X right in between in area 2. As you can see, the diagram is symmetrical, because if I say that if it's true that some bananas are yellow, it is by logical symmetry that true that some yellow things are bananas. And the last one is the O form. It is also particular and negative. It says the sum S are not P. Again, going with our statement, some bananas are not. Some bananas are not yellow things. That's why I place the X here, because I want to indicate that there exists some bananas. And as you can see, the X is outside area 2 and 3. It's in area 1. So there are some bananas. There exist some bananas. But these bananas that are in existence are not yellow things. Now, naturally, if I were to place the X right here in area 3, in other words, in the predicate family or category, I would thereby diagram that some yellow things are not bananas. Okay, the next thing that I want to review is the quality and the quantity. By quantity, it's obvious. The word itself suggests what quantity means. Quantity has to do with how many objects, how many members. Now, the quantity can be universal or particular. When we look at A form and E form, these two forms make statements that are universal, because they refer to all members. Okay, even though the E form denies, but it denies of all members. So the quantity of the A form is universal. What about the quality? The quality refers to whether the statement, the form, is affirmative or negative. So we say that the A form, all SRP, or all bananas are yellow, is a universal affirmative. Yes, you might have noticed that there's an X here. What does the X do in there? Well, the X is there because I'm using, in this slide, I'm using the traditional square of opposition. Now I'm going to cover that in a different lecture. But in a traditional, just very briefly, the traditional square of opposition makes an existential import or existential claim. In other words, according to the traditional square of opposition, there exist members, even in the universal affirmative and in the universal negative. You want to make they make existential claims, saying that there exist members of the subject. So the subject category, the subject class is not empty. There are at least one member exists. And also in the universal category, negative E form. Now the E form, I was saying the quantity obviously is universal because remember that it makes a universal statement. It says no, not even one SRP. But the quality is negative because it denies of all. On the bottom, there are corresponding particular statements, particular forms, or subalterns. The I form states that some SRP, and because it states that only some, you see, it's not a universal statement, it's a particular statement, only a few, only some. And the quality is affirmative of I. So I is a particular affirmative form, whereas the O form is particular but is negative because it denies of some. Some members of S are not members of P. Now the next concept that I want to review is distribution. Distribution refers to how many members of a certain category are also members of the other category. For example, take the A form. The A form says that all S are P. So an very easy way to remember the distribution is the following. Ask yourself, how many members of S are members of P? Well, the statement tells you right there. All members of S are members of P. Therefore, because all members of S are members of P, the subject is distributed. So, in the A form, the subject S is distributed. But now think about it. Just because all members of S are members of P, it doesn't follow, it is not true that all members of P are members of S, as you can clearly see. So not all, because all members of S are members of P, S is distributed, but because not all members of P are members of S, then P, the predicate, is undistributed. What about the E form? The E form is very easy because it says no S or P. So what does that mean? It means that all members of the category S are members of the category S. Therefore, S, the subject, is distributed. But what about the predicate? Well, same story. All members of the predicate family, are members of the predicate family. There, as you can see, area 2 is completely shaded in, which means that no members of any of the either category is shared with the other category. Therefore, both subject and predicate are distributed. When we go to the I form, once again, it's very easy to determine. If some S are P, it means that some P are S. Now, how many members of S are members of P? Some. And how many members of P are members of S? Again, some. So, because it's not all of them, then the subject and the predicate are both undistributed. And the last one, the O form, some S are not P. So how many members of S are not P? Well, only some. Consequently, the subject is undistributed. But how many members of P are members of P? All of them. Therefore, P is distributed. Okay. All right, now let's jump right into the three logical operations. The first logical operation, with everything that I have said so far in mind, first logical operation is known as conversion. Conversion is a logical operation where you swap the subject with the predicate. Now, the result of this operation is a new sentence. This new sentence is said to be the converse of the original sentence. Now, given a statement, let's say, for example, that all dogs are mammals. That's the original statement. Remember what I said before about shading. Because I want to diagram that all members of dogs, the dog's family, are members of the mammal's family, I have to shade in area 1. Okay? And therefore I say all dogs are mammals. Now the converse of this statement, as you can see, is not logically equivalent. So if it is true that all dogs are mammals, it is not true that all mammals are dogs. And you can clearly see that from the Venn diagrams that are not exactly the same. Now, in the E form, no dogs are cats. If no dogs are cats is true, then the converse of no dogs are cats, namely no cats are dogs, is also true. So as you can see here from the Venn diagram, they're exactly identical. They mean the same things. No dogs are cats implies that no cats are dogs. So a true E, the converse of a true E, is also true. And as you can see, in the E form, also the truth is equivalent. It's preserved in the converse form. Some cats are mammals is the equivalent to some mammals are cats. As you can see, they're identical. But the last form, the O form, is not going to be the same, because some fruit are not bananas is not logically equivalent to some bananas are not fruit, as you can see it from the diagrams. Now, to recap what I just said, only in the E and the I form, by performing conversions, okay, I preserve the truth value of the E and the I statements. On the other hand, the A and the O do not preserve the truth. And be careful, be very careful, because claiming that the converted proposition preserves the truth value of the original proposition in these two cases, in the case of A and O, will lead to the fallacy of illicit conversion. Okay, let's move on to the second interesting logical operation, which we call the obversion. Obversion means changing the quality of a proposition and then replacing the predicate with its complement. Now, the complement, what is the complement of a predicate? It is the class of everything else that is not a member of the predicate. For example, the complement of dog is non-dog. Anything that is not a dog, a non-dog, would be the complement. How do we perform the obversion? Well, 2 steps. Step 1, you want to change the quality. Now remember, the quality is either affirmative or negative. So, for example, changing the quality of an A form, all S are P, will give us that a negative, no S are P. Now notice that I just changed the quality, not the quantity. So if I change only the quality, I go from affirmative to negative, or from negative to affirmative. That's why I change from an A form to an E form. Great. The second step is to replace the predicate with its complement. Remember, the complement is whatever is not the predicate, a member of the predicate. So if the predicate class is dogs, the complement, remember, is a non-dog. Okay? And so I would change this from all S are P. This becomes no S are non-P. As it turns out, when you perform obversion, all the forms, by doing obversions, all the forms A, E, I, and O always preserve the truth value for all 4 kinds of categorical propositions. Okay? So in other words, you say exactly the same thing. If I say that all dogs are mammals, now if I say the obverse, if I say that no dogs are mammals, I'm sorry. If I say that no dogs are non-mammals, I'm exactly saying the same thing as the A form. And you can see it because I have double negative here. So remember that a double negative, what happens when you do a double negative? You do the opposite, you affirm it. Okay? So if I say that all dogs are mammals, I'm saying essentially that not even one dog is a non-mammal, because they're all mammals. And as you can see, I diagram both the original A form and the obverse form exactly the same way. In the E form, again, the E form is going to look exactly the same, the diagram, because in the original statement I say no dogs are cats, and in the obverse version of the form, the E form, I say all dogs are non-cats, which is exactly the same thing as saying that no dogs are cats. The I form, some cats are mammals, is logically equivalent to some cats are not non-mammals. Again, double negative, which becomes an affirmation. And the last one, some fruit are not bananas, is essentially the same thing as saying that some fruit are non-bananas, which is true. We know that some fruit are non-bananas, because not all bananas are fruit. I mean, not all fruit are bananas. There are many other types of fruit. Great, so obversion yields exactly the same statements, equivalent statements, and it preserves the truth value of all four categorical statements. Great. Let's now get to number 3, contraposition. Performing a conversion on a proposition, okay, so swapping the subject with the predicate, and then we replace both the subject and the predicate terms with their complements. For example, let's use all dogs are mammals. Step 1 is to switch the subject and the predicate, okay? So all dogs are mammals becomes all mammals are dogs. Step 2, now we replace the subject and the predicate with complements by adding non in front of the word, in front of the words. Therefore, mammals becomes non-mammals and dogs becomes non-dogs. And the result of all dogs are mammals is all non-mammals are non-dogs. Now let's see what it looks like when we diagram these things. Here we see a lot of very interesting diagrams. Now the first one, as you can clearly see, is identical. So the first contrapositive is logically equivalent to the original A form. When I say that all dogs are mammals, essentially I am saying that all non-mammals are non-dogs. Okay? So all things that are not mammals are things that are not dogs. And this precisely affirms the fact that all dogs must be mammals. So as you can see, the two diagrams, the original A form and the contrapositive, are exactly the same. We see the shading in area 1. Now, here's what gets interesting. In the E form, when I say that no dogs are cats, the contrapositive of the E form would be no non-cats are non-dogs. But you notice that here the truth is not preserved. Now, why do I shade the outside area? Remember, the outside area is area 4. It's the area that contains all the things that are not members of the subject or members of the predicate. So if I want to diagram the sentence, the statement, no, not even one thing that is not a cat, which would be outside, is a non-dog, is something that is not a dog, which would also be outside. Okay? So now I produced a sentence that does not preserve the truth value of the original. Also, in the I form, as you can see, I have 2 different diagrams, which means that the truth value of the original is not preserved in a contrapositive form. The I form says that some cats are mammals. That's why, as I explained earlier, we have an X right in the middle in logical area 2, to indicate that some members of the subject are also members of the predicate. But when I perform the contraposition, remember I have to say that some non-mammals are non-cats. Now, why do I place an X outside in area 4? Because, remember, you place the X where it calls for it, in a sense. Where it says somewhat. That gives you the answer of where the X is going to be placed. Some non-mammals. Now, how do I diagram some? Well, with the X. But how do I diagram some non-mammals? Things that are not mammals. Where are things that are not mammals? Right here, outside. Outside the 2 diagrams, because A is mammals and B is cats. So non-mammals is going to be right here. And some non-mammals are things that are not cats. Now remember that these are cats right here. A is cats, B is mammals. So I have to put the X away from the family cats, and outside, because I am saying that some things that are not mammals are non-cats. And the last one preserves the truth value of the original in a contrapositive. Because some fruit are not bananas is logically equivalent to some things that are not bananas, non-bananas, are not things that are not fruit. Remember? Double negative, so it means they are fruit. Okay, that's exactly what I'm saying when I say that some fruit are not bananas. And voila! I can say, a lot more about the 3 logical operations. But let me just review what I just explained. As you can see, the contraposition of statements A and O preserve the truth value of the original, whereas the E and I, the truth value is not preserved. So if you have a true E or a true I proposition, and you contrapose it and then claim that contraposed proposition is also true, you have to be careful, because you would be making a mistake known as the fallacy of illicit contraposition. Once again, I can say way more about these, but I want to keep it short and to the point. So I think this is the end of this great lecture. And that's all, folks. I'll see you in the next lecture. Thank you.